Okay, this is the P1 paper from June 2024. It's question number 5, and as we can see by looking at this question, it's a Radians question. Let's look at all the information they've given us. So they've said that this shape that they've got here is a plan view of a garden. It can be various different things, can't it? Okay, it's a garden in this question. Tells me that we've got basically a right angle triangle here, we've got a sector there, and then we've got another triangle here. That's not a right angle triangle. ABC lie on the line with AB is equal to 10.8. The radius there is equal to 6. They've told me the angle there. They've told me the length there. Okay, so no extra information particularly as I read through it. And it says, can we find the area of the sector BDE? So if I'm trying to work out the area of this sector here, it's going to be, oh yeah, perfect. I've got everything. It's going to be half r squared theta, and I've got both r and theta there. So let's jump straight in and get started with part A. I want area of sector BDE, which is going to be a half r squared theta. So it's going to be a half 6 squared times 1.3 radians. That works out to be 23.4 meters squared. And let's just go and check. They've said giving your answer in meters squared. Yeah, they haven't said anything else, so I could do it to any degree of accuracy, but that's part A done. Part B then says, can we find the size of angle ABE? So looking at my diagram, the size of angle ABE, which is that one there. Yeah, absolutely. Again, if I look at this triangle here, I've got all three sides, and if I'm trying to find that angle in there, that's just going to be the cosine rule, isn't it? With this being A and then B and C being, doesn't matter which way around we do B and C. Okay, let's tell the examiner what I'm doing. Let's get rid of those things off the diagram. So for part B, using the cosine rule, so using cosine rule, which is cos A equals B squared plus C squared minus A squared all over 2BC. This is one of the things that you need to learn because it's not in the formula booklet, just rearranging the cosine rule. So in this case, this is going to be 6 squared, it's going to be 10.8 squared, it's going to be minus 12.2 squared, all divided by 2 times 6 times 10.8. So given that cos A works out to be equal to, if you plug all that in, it comes out to 19 over 648. And so the actual angle ABE, is inverse cos of that. Making sure your calculator is in radian mode. Okay, go back and just check that you've got it in the right mode. And it says giving it to 2 decimal places this time. Okay, so if I want 2 decimal places, yeah, done that. So then part C says find the area of the garden, giving your answer to 3 significant figures. So the area of the garden is going to be the area of this triangle, which I've got everything to be able to do half BC sine A, or half AB sine C, depending on which formula you remember. We already know this one here is half r squared theta, but we've got it. So actually all of this is about working out the area of this triangle. So if I need to work out the area of this triangle, I really want the base and the height. I want these 2 measurements here. And I can get those. I'm just going to need to do a little bit of work. Remember, we've just found that from our previous work, we've just found that this is 1.54 radians. So what I can do now is I can work out this missing angle here, because it'll be pi minus 1.4 minus the 1.3. Once I've got this angle, I can use cos, as in right angle trig, I can use cos and sine both to work out the adjacent and the opposite here. So let's tell the examiner what we're going to do. Take a little bit of time. There might be a quicker way, but I think this is the most sensible way for me to do it. So, whoops, what we're doing here. So we're saying, just explain to the examiner what I'm doing. The area is going to be equal to the triangle ABE plus the sector BDE plus the triangle BCD. So for BCD first, for the right angle triangle first, angle DBC is going to be equal to pi minus 1.54 minus 1.3. Work that out on your calculator. That works out to be 0.3 radians. So then when I'm trying to work out the height and the base, when I'm doing this, I now know that this is 0.3. I know that this is 6, and so I can work out both BC and BD. If I want to work out BC, I'm going to say cos A equals adjacent over hypotenuse. I'm going to go nice and slowly through this. I know it's only worth 3 marks, but may as well not make any silly mistakes. So cos 0.3 would be equal to BC over 6. So BC is 6 cos 0.3. That works out to be 5.73 radians. I'll do the same thing with sine. Sine A is opposite over hypotenuse. So sine 0.3 would be equal to DC over 6. So DC works out to be 1.77. And then the area of the triangle is just half base times height. So that's half 5.73, oops, handwriting, 5.73 times 1.77. And apparently that works out to be 5.08 square meters. So that's the area of the right angle triangle. The area of ABE, that's just going to be half AB sine C for that triangle, so that's going to be a half 10.8 times 6 times sine 1.54. We have everything we want to be able to do that one there, so that works out to be equal to 32.38 meters squared. Already done the calculation for that. And then the total area is the 3 areas that we now have. So it's our 23.4, our 5.08, and our 32.38. But we only want it to 3 significant figures. So when you do all that and you add it to 3 significant figures, it comes back to 60.9 meters squared, and that's the last part, part C. Yeah, not too bad, that question. Took a little bit of time to do part C, but apart from that, relatively straightforward. Hopefully that all makes sense to everybody.